Okay, suppose that the function f is continuous on the closed interval from a to b and differentiable on the open interval from a to b. Prove that if the derivative of f is never 0 for any x in a, b, then there exists at most one value c from a to b such that f of c is equal to 0. This is essentially saying that there can be at most one root. There can't be more than one root. This is coming from the fact that the derivative is never 0, means that our derivative is always positive, meaning it's always increasing, or our derivative is always negative, it's always decreasing, and so it never switches between negative to positive, where you get multiple roots. We only get one root, at most one root passing through. Okay, so let's prove this. We're going to use mean value theorem. So here we go. Since f is continuous and differentiable by the mean value theorem, there exists a c between a and b such that f prime of c is equal to f of b minus f of a over b minus a. And by our assumption, the derivative is never 0, and so we can say that this is not equal to 0. And so the numerator is not equal to 0. So f of b is not equal to f of a for all intervals, because a and b are arbitrary intervals. Thus, f is a one-to-one function, and since f prime of x is never 0, f is strictly increasing or strictly decreasing. Since it's one-to-one and it's strictly increasing or decreasing for any C1, for any distinct C1 and C2 values, such that C1 and C2 are between A, B, f of C1 will never equal f of C2. This is coming directly from the definition of being one-to-one. Thus, we'll never have two roots, since two values will never be the same. So f of C1, if f of C1 is 0, then f of C2 can't be 0, because there can never be two distinct values which are equal. Thus, there exists at most one value such that f of c is 0. Cool.